Nice.
So this is,
can we get an intro from
yeah, I'm about to do
Chris?
it. This is Coffee Compiler Club. I'm doing an intro here for Chris because everyone else here is old hat or old school or something. So the meeting's being recorded, and if you don't like being recorded, you know, bail out now and watch it on Twitter. And I'll go live. I mean, I'll post it generally within a week. Sometimes I'm behind. I reserve the right to moderate, never had to do it. Anything to do with compilers, language runtimes, concurrency, locking, GC, typing systems, whether to null or not the null. All these things are all fair game. There's no set agenda. I sometimes start with an update on the language AA, and then the conversation goes where it goes. And here's Mark already. All right, so that's enough intro. I guess there's the obvious status update is that I've been doing these academic meetings with a bunch of guys who are much more type theorists and less on sort of professional compiler language runtime side. And we're trying to sort out the right kind of typing for AA, and you know what are my options and where am I at on that. That's been very fun. I've been learning a lot. That's also a work in progress. I've independently made a bunch of other progress. I have talked to not that group and not this group in a long time on, which I don't know if it's good, bad, or ugly, but I have a Henley Milner unification algorithm that I can run in a workless style, visiting things in a sort of arbitrary order instead of an AST tree walk, and get the same answer in the same linear time. I have a bunch of performance optimizations in there that are sort of straightforward memoization games. I have a global constant propagation algorithm that is running concurrently with it. And just this week, I am beginning to take facts from one of those algorithms to feed into the other to produce a better answer. So right now I have them in one way. Global constant propagation will tell me that an if statement is true or false on one or the other paths, and I will not unify on that arm of the if statement because that arm is dead, or the other arm is dead, or whatever. And that gives me a strictly better answer. It's a monotonically improved answer over either Henley Milner or GCP without this thing. And I'm working on the other direction now, and there'll probably some more stuff that'll come out of this later.
Does the workless algorithm imply that it can be parallelized? Not that there's any AA program large enough that would be a speed up yet.
None of the workless algorithms for doing global constant propagation can be usefully parallelized. Technically, yes, they can be parallelized. The overhead is fine-grained locking on the graph structures. The overheads of such lockings defeat. I've looked at this stuff from a long time ago. So yes, technically it can be parallelized. Yes. Whether or not you see a performance gain, I would claim would be kind of iffy unless you have ginormous programs. So there might be a version of that for global constant propagation. All the updates in the end turn into updating a single node's type, flow type, not Henley Milner type. And when you update a single node's flow type, you have a single point where you can do a CAS. I haven't tried that version. That might lower the overheads of doing this. You also have a worklist algorithm you have to watch carefully because you have to add people to the neighbors as you go.
Yeah, if you have to walk the work list every time you pull work off, that might lose right there.
There's now well understood how to do highly efficient, fine-grained workless distribution algorithms. So Douglas fork join does a really great job on this kind of thing, and you can get down to like, if the amount of work you have to do is above a millisecond, you can pretty reasonably distribute without any trouble. If it's in the microsecond range, you have to really do bulk work pieces. You have to take bulks off the main work list and mini batch around, which requires you to have many thousands of nodes in your graph. So if you're compiling it to the size of a function, you might have 10,000 to maybe 100,000. It's hardly worth it. If you're doing whole program analysis, you might have millions and millions, in which case, yeah, it might be interesting. This is for
think about stuff like the Google code base where they've got 10 million lines of code and the C++ takes 25 minutes to compile one file. Like,
oh, maybe
at really big scale, it might be worth it.
What I don't know there is it 25 minutes to compile because they spend all their time parsing headers? or they have pre-cooked the parsed headers, and they actually are doing a single compilation unit of such a large size that they have this much execution time. And then there's some algorithms. I talk about global constant propagation, like register allocation. The big part of performance in the end, once you do all the obvious shit, is register allocation, which, you know, I'm not claiming you're going to parallelize here. So
I think it's mostly macro expanding stuff that's been if-def'd out.
Yeah, that would be your header file, and I don't claim that. The right answer to that one is to pre-cache header files that have been pre-cooked, which I'm sure intelligent about.
I can add only also the function dependencies, where one function depends on the other function. That also takes a time, because you cannot discover the n-type results without the resolve the dependencies between the functions.
Well, this is C++ or C code, I'm assuming, so it's just in order. You picked up your dependencies one after another. I'm guessing, you know.
You have to, for example, Scala has a problem that in order to resolve what the function would be, it has to resolve all the functions it depends on, and so on and so on. It has to discover all the dependencies, and that takes time.
Yeah.
And they do it in, I won't say horrible, but they do it in like a sidestep problem. It's called something like lazy completers. When the function enters the body, it will when it encounters another dependency, it will build a not build. It will mark a stub, and it will trigger its completer when it actually meets its dependency.
Right.
And that allows you to lazily discover the dependency graph of the functions.
Yeah.
But
C does not have this issue.
Yeah. Yeah, because you have to annotate the function in C.
Yeah.
It can know its return type immediately.
Yeah, just the act of touching the description for a function tells you its type, and you're done.
I arguably would say that lazy completers are a cool feature, but the problem is that you are not very cache efficient. You have to constantly jump between the heap, and that won't make the program compile much faster.
Right. I have seen the Scala coding style, and I don't know in Dotty if this is what's going on, but my guess is they don't do the right kinds of memoization and caching of the IR proper, and that tremendous pressure and activity.
Huge improvements in the cache department. It has a very in Dotty, but still use the lazy complete style in order to resolve the signatures.
Oh, there you go. Sure, let's do that first. Hey, Chris, why are you here?
I work at Shopify. I lead a small compiler team working on Ruby compiler research. I've got interests in graphical IRs, visualizing graphical IRs, making them understandable to non-experts. I've got interest in just-in-time compiling through embedded little languages such as datetime formatting expressions, printf formatting expressions, things like that recently. That's the kind of thing I work on.
Gotcha.
Are y'all using Ruby JIT, or are you using the interpreter?
This Truffle Ruby, which is a just-in-time compiler for Ruby, it's based on Graal and the Truffle framework.
Yeah.
But I write multiple Ruby JITs as side projects. So I released a side project last week called Rhizome, which is a project to try and educate about how compilers work that is deep rather than narrow. So I see lots of blog posts that are talking about how JIT compilers work. And they often talk about bytecode, then they get to the point of template compilation. So they'll have a snippet of machine code for each bytecode. That's sort of as far as they go. It's quite hard to find anything that's approachable to almost anyone below that kind of level. So what I did was I decided to go deep. So I wrote a just-in-time compiler for Ruby that had a bytecode. It had a abstract interpretation to build a compiler graph. It did inlining on that graph. It did pruning control flow to do de-optimization instead. It did GVN optimizations like that, and then it's scheduled and code generated from that. So it doesn't support much of Ruby, but the idea is it's deep rather than broad. And it's very hard to find anyone talking about basics like scheduling in compilers that's accessible outside of sitting next to a compiler engineer. So actually project worked on recently.
Well, throw a link to this project in the chat.
Will do.
Unfortunately, we have a person here with knowledge with the JIT compilers with the size of, I don't know, the Library of Alexandria in Greece.
Yeah, I know a little something about this topic. I tried for a long time, the visualization side, I tried for a long time, and I know the Graal guys tried for a long time to do visualizers for the Sea of Nodes IR. And it was always a mixed bag. I ended up only ever doing development where I had fancy pretty printers that would just do ASCII gram dumps with indentation at best. I did, like I said,
the ideal graph visualizer. That's what Thomas Worthinger built for Graal. Yeah. So
yeah.
I've got a project that's an open source equivalent to that. It's called Seafoam. That does graph visualization. What I'm trying to do is, so IGV shows you exactly what the graph is, right? It's literal. What Seafoam tries to do is it takes some liberties with showing you what's there in the graph to make it more understandable. So it's not useful, you can turn them off obviously, but those kind of things aren't useful if you're trying to debug the graph. But if you're trying to look at the program and understand what's the shape of this, where are the loops, what's going on, where's the performance going, these kind of annotations and sort of slightly bending the truth make it easy to understand. So for example, in my languages, I often have arguments that come in from an array, and that adds quite a lot of overhead to understanding that something is simply an argument. So I replace those with a node that doesn't really exist. It says this is an argument, and I know that it's read from an array and stuff like that, but I don't need to see that polluting my graph all the time.
Right.
So I sort of try and apply some things to make it more readable in practice rather than just literally showing the graph. And I do things like I cut edges off that I know make the graph very complicated, but aren't really necessary to read. Because if I know where something comes from, everyone knows where something comes from. We don't need to see it making the graph very complicated.
Yeah, maybe. You know, I did sort of graph visualizers for doing the layout and then color codings. And then I always had a horrible layout, so I went into things that would let me animatedly, manually shuffle things around till I got the layout I wanted, which helped in the understanding, but it was not a process that was amenable to like printing or anything, and it was too slow. The major thing that I did out there that was good was getting like the loop structures showing up with color coding and the like. I didn't play the game of cutting out a lot of the dumb edges, but there's a lot of dumb edges. All the you failed go uncommon trap because a null failed or a class cast or whatever. These things that haven't failed ever yet again, whatever, haven't failed yet.
Yeah.
You want to have some sort of short form says that this test exists and is here, but you don't need the whole 9 yards of bail out and go over there.
You almost want it to be profile guided.
Interesting. Yeah, and the other piece that I would think would be useful, and maybe you're doing already, is to compress things that you know have a shorter form that because it's typically done the following way. And then if I double click some node in the graph, expand out the full 9 yards. But if I don't care to see your argument being loaded from an array with like range check and all that crap, that you'd rather just call it an arg, you know, you can double click if you want to see the
I've got an aspiration to build a website that you can go and upload your graph to, and then people can go and collaboratively like annotate it. So you can say, I'm compiling this, it's not doing what I think it should be doing. Why is it so slow? Upload your graph, an expert comes along and like double clicks on the node and says, well, this shouldn't be here. And the reason it's here is because of this. Go and try tweaking that. And it'll be a sort of collaborative thing.
Tell you that the most productive use I got out of expert looking at shit, me, was getting the Azul JIT to cough up annotated machine code that had, you know, hooks to the Java and bytecodes it came from and hardware performance counters annotated. And then I could display the machine code or the assembly to a programmer who is not an expert, but they would get suddenly, oh, all this crap, and oh, look, right here I've got some fucking interface call in the hot inner loop, and it couldn't, shouldn't, would it, didn't inline, and what do I do about it? I have to go manually deal, whatever, fine. That was very productive. I used that technology a number of times with people and got them over the hump of understanding why it did or didn't do what you wanted to do.
Yeah.
The graph thing was cool. I just never used them myself productively. I've used them and it was never. Yeah.
One problem we have is you have to reduce your code to something of a minimal example. If you try it on a real production, especially Ruby code, where it's just so complicated.
Right.
So, yeah.
Yeah. Sure.
So people have to do a reducing to start with stage, which is a bit tricky.
Yes. Well, this is all about power steering, which is a humans involved in the loop of producing something, and then that makes it really complicated.
Yeah.
Like I said, I always did ASCII dumps was the way to go for me. You know, fancy, smart, intelligent dumps, but ASCII dumps.
So I work in a team with some quite senior people and some quite junior people. I spend a lot of my time mentoring and trying to train up the junior people. So this kind of anything I can show them visually and show them working through is really good.
Oh, that's a good point. Yeah, yeah. At the time I was doing a lot of this stuff, it was only me and people who'd been working on C2 for a long time. Yep.
Yeah. But it's an ongoing problem, right? There's almost no way to get into compilers apart from sitting down next to someone who works in compilers. The information just isn't there otherwise. But I've had great success with taking on people who, we had someone who had just left high school and she did some mentoring with us. And by the end of it, she had a top of Hacker News blog post about an optimization we added to Ruby to optimize real world patterns. And you can achieve that if you intensely mentor someone. Yeah.
I think that the youngest guy I picked up as a mentoring at Sun is Zim Jiva. He's a good guy. He's a manager in some startup in Austin. He was fresh out of undergrad, but not high school.
Yeah.
That's
Carol Chen.
Nice. So what else here? What do you want to know about JIT'ing that you don't already know? Sounds like you've been at it a while. And the Graal guys, I mean, I've known of them and talked with them and stuff for years upon years upon years.
Yeah. Like what issues have I been working with recently that are tricky?
Well, because I'm playing typing games on a language where I'm using essentially a C2 style IR to do the typing. So on one hand, it lets me, I believe, type very quickly compared to what I hear and see horror stories from other folks. On the other hand, it's a non-standard way to type. So I get to go cut some new ground on a lot of fronts on what it means to be a type and how you represent them and how the algorithms go. So there's a major change to Henley Milner algorithm I've already put together.
Because graphs often have extra typing information. It's called stamps in Graal. I don't know if it's called that in C2 as well, where you add type information along an edge. So you can say this integer is within this range because of this.
I don't annotate the edges in C2. I annotate the nodes, but the types in the nodes can be as precise as you have the typing system, which certainly included ranges in C2 at Sun.
Yeah. So it's interesting because there's a whole parallel type system there that isn't visible to the programmer in Java that the compiler is working with and understanding.
And typically the C2 and Java code will reverse all of your types that you threw away. The extra type annotations that came with generics, that's what I was trying to say. C2 picks a lot of that back up.
Yeah, rediscovers them all.
Rediscovers it, right. And of course, none of that's discussed with you. And if you didn't have a generic, but you were using it in a certain way, he often picks that up as well. So if you just have a bare hash table and you're stuffing strings in and pulling ints out or whatever the hell, he often can pick that up because he's inline enough the hash table that he gets it. Not saying 100% or anything like that, but that's the reason I started on this typing using C2 as a typing system. So the core IR, and I don't know what Graal did here, the core IR for C2, the edges are unlabeled. There are bare pointers, and on purpose a bare pointer because it's more efficient. And occasionally you must label an edge, then I make a node for it instead of an edge. So technically it's a projection of a multi-producing value. And that's the only reason to have an edge label. Everyone else, I don't think
they're labeled. Like the ports coming out of the nodes are labeled based on what they are.
Yes. Which
I think is a bit more than C2 does. C2 tends to rely on positions of the ports rather than the names, doesn't it?
If you're going from use to def, then it's ordered and the ordering tells you the semantics. And if you're, so like subtract of A minus B, you know, A's in slot 1 and B's in slot 2, and slot 0 is control, which is empty for subtract, so fine. But if you're going the outbound edge, so an if statement has a true and a false, then those have to be edge labeled, because the outbound edges are otherwise just a work list, just a list, unordered. And so the edges are labeled by putting a node in there that's the true projection and the false projection on an if. And that's all sort of, I mean, I know Graal heavily copied from C2, so I'm suspicious that they do something very similar. And there's papers and stuff that talk about this kind of thing. But the end goal was performance and small footprint for the compiler, and that was only label the edges that must be labeled, and label them with the same node technology as everything else. And that turns into a lot of performance and small footprint and shit like that. So that's the reason that went that way. I know different people have different ideas of what should be going on in the compiler for how you do your IR, but if performance of the JIT is important and the C2's JIT is fast, there's design choices.
So Ruby's pretty dynamic and kind of has hash tables all over the place. To what extent can you replace those with structs and only deopt if the user does something weird, like add new fields at runtime?
We don't replace them with structs if you mean like a shape system. That's something that is an open piece of work if someone wants to do.
I mean, that's where
somewhere.
V8 gets a lot of its speed.
Yeah, but that's because of all things are like hashes in JavaScript, so it's a bit more essential for them to do that. But yeah, it's a missing optimization for Truffle Ruby. We do some stuff with hashes. For example, we can Scala replace them. We can inline through things like mapping and indexing and iterating over them really well. But we haven't tried doing a shape approach on hashes yet. I think most people would recognize using a hash like an object as a bit of an anti-pattern in Ruby. I don't think it occurs that much, but yeah, we should try and do that work, shapes on hashes. I was starting to see shapes on things as one of those patterns that turns up everywhere. So in Truffle Ruby, we have shapes on frames, shapes on objects. We have shapes on like matching regular expressions and stuff like that. And we should have shapes on hashes and stuff like that. It's one of those things that you keep reinventing it everywhere. You realize it's the same everywhere. We should do it once and do it the same way.
Yeah, it turns out structs and arrays are really useful ideas.
Been reading up on Swift and their take on structs versus object instances. That's a different twist, but it's another good one. It's structs are by value only, and class instances have an identity and can be shared, and so you can mutably update one and somebody else will see the updates, whereas structs are by value only, and so you don't get to you get a version, and then they do cow optimizations under the hood, so they don't have to copy everything all the time. But there's a useful property there of claiming sharing or not, or side effects or not. So I thought, Cameron, you were going to jump in there.
Tempted.
Fine. What else?
In Ruby, do you find you have the auto promote problem, that you have something that needs a wrapping integer and you end up going 1 over and it becomes a big int, and then you have to modulus it down? And
what we
like implementing the Java string hash in Ruby can be surprisingly slow.
Yeah, so a pattern we sometimes see is people do some operation that turns it into a big integer, and then they use an and mask to keep it within range. But because of Truffle Ruby, Truffle's whole philosophy is local optimizations only. It only does local optimizations. You're only supposed to optimize based on the input you get, and that's all you're supposed to know about. So it's very hard to do a non-local optimization where the issue is, someone's about to mask down to a small integer, but you can't see that because you're supposed to just know what your input is. So again, that is actually an open problem. I'd like to try and solve that using stamps information from the compiler. But yeah, that's actually a great question, because that's if anyone ever asks
something
you,
like A or 0 plus B or 0, put that whole thing in parentheses or 0. Like you know that thing's a 32-bit int the entire time, or a 64-bit int the entire time.
Yeah, I mean, if the values were just 32, the compiler would be able to optimize all that together. But as soon as you start using big integers, you start to get runtime calls, which the partial evaluator sees as a boundary. So it can't remove them when they're in, because it sees them as a side effect that it doesn't have responsibility to look after. So if anyone ever asks you what's a downside of the truffle approach, if they're evangelizing truffle, it's getting non-local optimizations before the compiler start doing.
How far is non-local?
Anything apart from your input. Truffle nodes are supposed to operate on their input only. Sometimes you can add extra information by adding like little tags on objects and stuff like that. But if it's what's going to be done with your results, there's no way in Truffle for a node to think, oh, I'm about to be masked back into a reasonable range, therefore I will not produce a big integer in the first place. There's just no mechanism for that because you're not supposed to look along your chain of nodes to who's using you. So
right,
it's tricky.
Right. C2 definitely does that in limited context.
Well, Graal does it when it gets it into the compile stuff, but because of Truffle is like operating at the partial evaluation level,
right.
As soon as you've put that runtime call in, you can't remove it. And I've got real examples of Ruby code where there is actually an issue. So that's a second excellent question. I know you've got these excellent questions about the limitations of my work lined up, but yeah, that's another interesting problem to solve.
So the next question down here is I look through the chat thing. A+1 becomes a big integer, and you mask it down to 32.
That's exactly it. Yeah, and we see this in graphics code. Yeah,
right.
I've got benchmarks with this.
Right. Why isn't the and guy look to his left and see a big integer creation call of something else and just peek through it and say fuck the big integer call, and the optimization here is A+1. Done.
Yeah. I mean,
not big integer, not an point.
The philosophical answer is because of because of that's not the truffle method. Truffle method is to look at your inputs only. So the system isn't set up for you doing it. So
I'm saying
possible, but not easy.
The guy looks at his input and sees create a big integer as a function call.
When I say input, I mean the dynamic input, not the type of the node that is the input. So I mean the actual value. Truffle nodes are supposed to look at the values that come into them. But also we'd often find in Ruby that there's like one level of indirection between these two operators in practice, which even if you could look at your direct input would start to defeat it. So there's a couple of reasons. Just historical, people don't tend to do that in Truffle, so the system doesn't make it easy. And second, especially in Ruby, we'd get indirection that would often get in the way. But yeah.
Okay. Yeah. The C2 philosophy was pretty much only look at your inputs, but definitely look more than a few afield. You went further afield than one. And that turns into like worklist algorithm issues where if I modify something, I have to throw more than you might expect on the work list to go verify I got everything. But that was always handled on a case-by-case basis, and
we're okay in this particular case because we can specialize for a 64-bit integer, even though the actual result is 32, and then
pretend I'm 64-bit. I'm going to big integer to
then it's a problem. Yeah.
No, if I put more F's out, are you going to blow up on me still? Right? I didn't put enough F's here, so 1, 2, 3, 4.
Yeah, then we would. Yeah.
Right, that one. That's the one I meant. I was just being lazy on my typing. Fine.
Yeah. So the compiler Graal would say a runtime call. I would think that was non-negotiable to remove the runtime call, unfortunately.
No. Yeah. Right. Okay. So certainly C2 has what you say is a runtime call. He would have an intrinsic node, which would be implemented as a runtime call in the worst case scenario, but known to have fixed semantics to the compiler IR.
Yeah. So really, we should teach Graal about big integers. Possibly is what we should do, but again, that's kind of against the philosophy.
Yeah, I got it. I'm just saying that there's a way forward here. You might have to debate on. The thing that I ran into in C2 a lot was because I had a lot of these ad hoc go further field. The updates to the work list was ad hoc, and you missed stuff, and you couldn't sort of maintain it long term in a perfect order. And if close was, horseshoes and hand grenades was close enough, you were great. If you wanted to be perfect, then it got very nitpicky and fiddly. And so at some point we gave up, and so you occasionally missed a few of these things. but you missed a few, statistically speaking, tiny, and walked away from
I'm
it.
wondering if the generalization you need here is pure functions. So that function call that Graal doesn't want to play with, if it knew it was a pure function, then it could be free to look at it and go, I can collapse all of this.
It's
given the,
looking further
use case.
afield than just your immediate input. So there's a side effect issue if he's not pure, which I guess that's the, okay, never mind. Answer the question. If you got rid of the side effects of the runtime call by declaring an intrinsic that was pure, would that work?
Yeah, it would.
It would. Okay.
Yeah.
C2 had the knock-on problem of, because you look more than one field, you had to do worklist update games. And I've been playing with this, AA language IR, where I'm trying to be perfect on how these updates go. And the issue is it's either a lot of nitpicky, I'm better about it now, but there's still a lot of nitpicky, or I have to officially draw a peephole optimization ring around the graph, and all inputs and outputs can be tracked perfectly. But the code that touches would then have to name all the edges of the peephole region in some way that it's easy to modify and edit and change, because these things change all the time. This is, active compiler under active editing. You want some support in defining the perimeter. Once you define the perimeter, it's easy to throw all the neighbors on the list and that automated behind your back, and you get the perfect answer out and all that. Find the perimeter. Okay, well, find the perimeter by naming all the parts is like a big pain in the butt, because you're just exploring if the following conditions, then if the following conditions, if, and you went further and further afield until you finally, so your perimeter got lazily expanded as you went. And then suddenly you realize, oh, he's just doing a stupid +1 in a loop because it's the index variable. I want to yank the whole thing and declare it not a big integer and all that, or whatever you're doing. I don't know. No. Yeah, this is your.
This would be easy anyway if Java had better big integers that had intrinsics, but it doesn't. The big integers do crazy stuff.
I would claim the other way around, that because of the performance model.
In the LLVM framework, I think actually is, besides having a large kind of like properly engineered framework with large code base that people can.
Oh gosh, I'm confused by it. Okay, fine. I was trying to follow Cameron's video link at the same time, and somebody was talking, and his voice I didn't recognize. Shit.
I was switching to see who is talking. Is it possible to hold a big integer in multiple registers? It's like a force in 2 or 3 register.
No.
Somehow.
No.
No.
It can be a million digits long. Compute the billionth digit of pi. Well, there's a gigabyte of RAM right there. Right, that's the whole point.
But you should be able to be optimistic and say, if I ever add 2 64-bit integers, assume that they don't overflow and deop if they do and recompile the first time.
Right, they go miles and miles long. SunSpark has add overflow carry bit adds that would do a tagged integer add and flip a special exception of some kind if you overflow, so you can catch and immediately inflate them or do whatever you're going to do. x86 has support for this. Everyone's got support for this. And the answer, of course, is if you ever use that support on all your integers without any further to do, you take like 10% to 50% slowdown. It's a big hit because they're just freaking everywhere. And
it's a smaller hit than boxing it as a big int.
But it stops you using addressing modes for arithmetic as well. People say JO doesn't cost anything. It doesn't really cost anything, but it stops you putting stuff in addressing modes, which is much quicker and much more compact.
Right. In so many things. So what the V8 guys do, which is what I would recommend you have to go down this path too, is you do a bunch of type analysis where you get big chunks that don't overflow, not one by one local, big chunks that don't overflow. And then you do the whole thing. At the end, you look for any overflows, then you bail out and redo the calculation in the overflow version, right? But you do the overflow check rarely, and in the chunk in the middle that you're assuming no overflows, you do all the fun games with the offset math and the index checks and everything else. You do all the right way. And so you have to figure out how to cut down the set of overflow checks that you do if you have a model which says we can overflow anywhere and immediately inflate. And I think this is where I think Java did it right, in that if you know you're going to overflow, you generally know you're going to overflow. I mean, for say it another way, if overflow is going to be an issue, you generally know it. Typically, it's not an issue and you never need to worry about it and you're just fine. If you're ever suspicious you're going to use an overflow, switch to using a big integer and pay the cost and deal with the overflow. But you generally know it's not an issue. I don't care. I don't want to think about it. I'm just going to use raw integers. And if it overflows, something bizarre happens only much later. And it's my bad for not recognizing overflow is actually a problem here. 64-bit overflow. I wouldn't do this with smaller versions of the integers, but 64 bits, yeah.
Yeah, all this complexity with like overflowing is why, at least in my language, I removed automatic overflowing to begins.
Yeah.
Because the sheer amount of code needed for just something as simple as integer addition. Because you can have, normal int plus big int, two normal ints, big int plus normal ints, and big int plus big int, and they all require like different approaches, slightly different code paths.
Yep.
And I had some macros for it, and the macros themselves were like 100 lines of code. And that's then expanded into like an ungodly amount of stuff.
Yeah.
And I think like I find it also leaks into, or leaks maybe not the right word, but it shows up in places where you don't want it.
Yeah.
So you have like, let's say, a piece of code that accesses an array by index, for example. If you can overflow automatically, that index might be a big int, and probably your sort of underlying data structure doesn't support anything bigger than basically the word size.
Yeah.
So do your ints just wrap, or do they throw?
Well, that depends, of course, on your language. In my case, I decided to have them wrap around, simply because I can't really think of a use case where your array index would be greater than 64 bits, basically.
So the use case that I tend to see is somebody is trying to exploit a security vulnerability in your system because you in some way assumed that a positive number plus a positive number is always a positive number. And if they can force you to get a negative number, they break some piece of security logic that you wrote because you didn't realize two positives can add to a negative.
That's Java range checks, which can be shown to be extremely cheap.
Right, but so in that case, at least what I'm doing now, like in my type system, I introduced the difference at least between signed and unsigned integers. Because I also have quite a bit of code where, especially with IO stuff, the size given back is a unsigned integer. In case of Rust, it's the word size. But prior, my integers were always, Rust gives back an unsigned integer, and my integers were signed with automatic overflowing into big integers. I tore that out, and so now there's only signed and unsigned 64 bits integers. Big ints will be a separate type, basically. And these operations, they, if you say you read it, you get a file size back, and it's too big to fit into a 64 bits unsigned int, yeah, it will wrap around, but it won't suddenly become -5 or something like that. And similarly, things where I take an int, like say accessing an array index, that case is a bit more tricky because I support negative indexes to access from the back. But say you didn't, again, they would just wrap around. You wouldn't get some bullshit number that's -2 billion, whatever. And prior, it would basically panic. I think like the VM would explode very loudly.
So the hotspot, we went down all the possible things you could do with range checks and optimizing them and getting them nitpicky correct. So one of the useful things I had out of the Russians as a testing group, they put together the most hideously evil tests. But amongst things were like, for I equals 1 to n with an offset of 2 billion, and n turned out to be -2 billion or whatever. They had fun games where they would start with things that were positive billions and add negative billions and get integer wrap that was correct and shouldn't explode, or incorrect at some point by 1 left, right, or up or down. And we ended up getting all these cases beaten out and still, do for loops with range declaration correctly. But boy, it's a non-trivial task.
Yeah, and in my case, like accessing indexes, it's not sort of checked in the sense that it will error on certain values. It's because I support negative indexes, there's this sort of implicit checking going on where you say, oh, if it's below 0, we do it this way, and that will always produce a positive number.
Python-ish thing. Yeah. The other thing going on is that you want to have 64-bit math for your integer, for your indices, because if you have 32-bit math for your indices, then you can't actually use the x86 signed offset math guys, because if you end up with the wrong sign, they'll do the math and he'll wrap the wrong way and blow out on you without having a mask up front. Like you add an instruction every time on an x86 doing array math in Java over what you would need to do, because he does a sign extension in the wrong way. If you have a large integer index scaled by, say, 8 bytes per, and that wraps. He chops it at 32 bits, wraps you, and gets you the wrong address. He needs to sign extend to 64, then scale by 8 and add it, and he doesn't have that in an instruction. So if you just have your semantics being that your indices are 64-bit, then that problem goes away.
Yeah, I decided I'm just going to make all integers, 64-bit similar floats, always 64 bits.
Yeah.
Yeah, there might be cases where you don't want
size as
that.
an option for the storage when you have lots of them.
Right.
But when you're running in the processor, that should be all.
Yeah, and for me, the underlying reason there is more like, yes, there are still 30 bits platforms, mostly in embedded, but one, I'm not targeting those.
No,
my language won't fit there anyway.
That's not the issue. It's
no, and so then it becomes more like, okay, I'm not specifically targeting 32 bits. What is easier? Do I make them just word size, so it's platform dependent, or just a fixed size? So like, make them fixed size.
No. The programmer, this programmer, but there's a class of me's, wants to be able to specify the storage class for the value, because I have billions of them. And if I go from 64 to 32, I cut my billions in half. And that's an exciting optimization. So I want a storage class on the array set that says I'm willing and able to truncate the hell out of you. That's just fine. But when you're running in the processor and CPU, it's all 64-bit all the time. Fine. But if I have a bunch of low precision, like doubles are all 64 bits. Yes, but my data came from a sensor who's got fucking 8 bits precision. So I got a 64-bit float out of it because that's what I'm going to get. But it's not more accurate than 1.23, and that's the limit of its accuracy. So I want to store that in the smallest reasonable floating point format or whatever format I can, because I've got billions of sensor points. They're flowing in at a super high rate, and I have volume issues, and I want to be able to shrink and store. And then, yes, exactly. bfloat 16 is one of the kind of options you look at there. There's a bunch of these things, but you want to have a storage class where you put the thing that's sort of easily done in the language. The other ones you get 8-bit integers or 16-bit integers out of your A to D converter, and you have them by the billions.
Do you need language support for that, or can that be a user-defined type?
No, you have to have a language support for the storage class in the array. I want an array of 16-bit elements. I want an array of 8-bit elements. I want an array of 32-bit elements.
I would argue that really depends on the language. Like I'm probably not going to add something like that, but it's simply because I'm not building a systems language, for example.
It's not systems. I did machine learning on Bluetooth sensors. I have a factory floor. It's got 10,000 Bluetooth sensors. It's got 1,000 Wi-Fi's that give me a really lousy signal from hundreds of Bluetooths every second, times 10,000s of them, times 100 of these things. And I'm trying to do triangulation to locate where these things are on the factory floor. Suddenly I have a flow rate of a couple 100,000 to 1 million points a second, whose accuracy is known to about 8 digits at best, 6 to 7 digits. I need to do machine learning on them. So I want to throw them in a big array and make pass over pass over pass. It takes about 5 to 10 passes, depending on what I'm doing. Do trilateration and do a couple other approximation things and a bunch of missing imputed values and blah, blah, blah. And that turns into a pretty picture on the screen, and some factory manager's overhead view can look, and he can filter and see where his shit's running around, where the forklift is at the moment, all that kind of stuff. But that's not a systems language that I would claim. I'm doing machine learning on a high flow rate data. So Java is perfectly fine here.
Right. Systems language might not be the best term. Not sure
I can't write an OS
category
with Java,
language,
but I can do machine learning on big data.
Right. It's more like, I guess my point, like in a language like Ruby, for example, this wouldn't be useful. Like nobody would give a shit because that's not what they use Ruby for example.
No one does machine learning in Ruby? That's a question.
There is a library.
They haven't finished yet. It's still running.
There's at least one guy who does machine learning Ruby. He maintains a machine learning library all by himself.
Okay, fair enough. Fair enough.
Has anyone here looked
Can't we do this stuff and hide it from the user? So like in my Ruby implementation, if you have a Ruby array, it could really be an int32 array, an int64 array, a float array, and the user doesn't know. They get the most appropriate one for them. And you could have a,
right.
I don't know if anyone has ever tried using smaller floats based on the values. I've never seen that tried before.
You have to know something about your data range to know that it's okay to shrink. Yeah. So this is a question for the user. Hey, would I shrink it here? Like no one's going to use bfloat 16 unless they really know.
Cliff, on floats, I can understand that because you're going to leak information as a side effect when you're using floats. But with integers, I mean, from the guy who actually built Hotspot, I'm really surprised you'd argue that.
What, small integers?
No, just integers in general, because in theory, if you own the runtime, you can inflate the array to whatever it needs to be lazily.
We missed on our. Let me try again. This is a thing where the programmer's internal representation is only 64 bits in the core CPU execution model. It's just what.
Oh, got it. Totally fine. But the point is for storage,
Yeah, but
if they try to store something greater than, so think about dependent types, for example, right? You have a type. It says I need to store a value between, let's say, the really imaginative, and they say between 0 and 100 trillion.
The programmer adds an annotation, is what you're saying, that says this is the range I'm interested in?
Yeah, that's what dependent types let you do. Sure.
Yeah, that's exactly what I'm talking about, having these arrays of smaller element sizes.
Right, but then the runtime says he's never stored anything bigger than the number 3. Why am I using 64 bits?
Yeah, so that's not necessarily the issue, but you're correct, and you could go there. Although there's a real performance problem again. You have to. That's a fine line to walk because it only counts if you can overcome the cost of checking every element going in and out of the array versus the volume of data.
Saying it's a fine line to walk when you're on a call about compilers is kind of silly.
Okay, fine. I looked at some of these performance hacks at different times in my life. If I know the count of elements is in the millions to billions, then a sweep periodic over the array to verify that small and verify sizes are within a range. And you have to range check every element getting stored in to confirm that nothing inflates the array. And then if it inflates the array, you have to stop and unpack the array and all that. It's vaguely doable. And I claim there's a performance issue that you have to watch carefully. That's what I'm talking about, the fine lines. A lot of engineering that you don't roll backwards in performance in a big way. Whereas if the user just comes along and tells you, I know for a fact that I don't care about values beyond X, just truncate when you go in because the truncate will never do anything.
And obviously concurrency plays a pretty big role in what's easy and what's not easy.
In this case, I am concurrently adding to this from multiple, like the server's taking beats from multiple directions and multiple threads.
Yeah, so concurrent
So would you play the same game that you did with concurrent hash map? And say, if I make a thing that doesn't fit in the array, I'll make my new array that's the new size.
Right.
And as people read, I do some copying over from the old array to the new array as you're reading it in a concurrent hash map kind of style.
In this case, because it's an append-only structure, which is typical of IoT things, it's an append-only. There's a much simpler solution. You do arraylets, and you keep adding on to the arraylets. And you just have to do a concurrent or locking or whatever when you add a new arraylet.
So if I have a billion things that are between 0 and 255 and one thing that totally blows it up, then I just say, okay, I'm going to chunk this into 1,000 elements at a time that I'm going to store, and only the one chunk that has the bigger element in it gets enlarged.
You actually have to be, this is H2O story. You have to be closer to 1 million before it pays, 100,000 before it pays off. But yeah, then it pays off. But the H2O story then was the math did reinflation had a custom destructor. And what I last did with this is because I knew none of the values they all gave me digits beyond, 6 or 7, and all those digits were random. So I just ignored them, and I didn't have to do the deflation trick where you have to ask the question of the array, what kind of an array are you? And how did you store your data? But the H2O story was, yeah, you compressed on a 100,000 point chunk. This is not the Java JIT version, but this is the manually done JIT version where you dynamically pick the size of the array to keep the data volume small.
Has anyone here played with Crystal, which is a statically typed language that uses those static types to be faster, but in theory smells like Ruby?
Throw the link. I've not heard of this.
I've looked at it. Yeah, it's a contender for the next version of C, if you will.
Really? There's a lot of contenders for the next version of C for a long time.
Yeah, but that's the space it plays in.
Okay.
It used to be globally type inferred. I think after a period of time, they walked back from that and started requiring type annotations because they found it was taking a long time to globally type infer entire programs.
I'm going to attempt global type inference. I'm curious to see if I get, well, I don't have any programs that will be big for a long
time. No type annotations whatsoever.
No, they're allowed, and you want to use them for good reason, programming understandable and documentation, blah, 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 but no requirement for any type annotations. Yes.
It's also a language out of South America, by the way, which is
that's interesting.
Fairly unusual. Pretty cool.
It is, but I've seen good work come out of some of these countries, so I'm not going to ever claim.
Lua partially from Brazil.
Brazil, yeah, a bunch of people in Brazil have a strong programming thing.
Yep.
You hear about Bulgaria, the Eastern Russians or whatever.
I think Crystal's from Argentina, if I remember correctly.
Well, yeah, here's Tidior, right? So he falls right into the camp. So I got a bunch of guys in Prague, Vienna I've worked with. Oh, God, I can't remember now countries, but there's a bunch of Eastern Europe.
St. Petersburg, obviously.
And St. Petersburg, obviously, yeah. Well, I've been there a couple times too.
I would add Italy to the strong C programming. I don't know why, but they have some kind of tradition. They are pretty much strong C programmers. Like, for example, Redis is by Italian programmer. I don't know. There are a bunch of projects, but Italian programmers are pretty much strong C programmers, I would claim.
Yeah, okay. I don't know. I'll stare at it in a minute. Looks reasonable.
Yeah, I've been watching it for a few years. I like a lot of what I've seen there.
Okay.
Did we leave some kind of homework from the last session? I tried to remember.
Oh God, there was so much going on. I continued the last CCC session or the last?
We ended with the futures by Yorick we were trying to explain something, but I think we set things for the next time. Something example.
I don't know. It feels like continuation passing is always going to stress your garbage collector.
That's interesting. So I'm looking at the last time's chat. Someone talking about, we weren't talking about continuations last go around. We're talking about AA syntax, for loops and the like.
We end up with futures, I believe. Yorick was trying to explain.
It didn't show up in the chat. Which
no,
am I missing something? I thought futures and continuations were sort of isomorphic of each other. Did I miss something there?
Yeah. I mean, yes. As far as I'm concerned, they're isomorphic. They're independent.
Okay.
I did a lot of stuff with continuations in H2O that worked out well for me, but but it wasn't the same thing. Like continuations have what's a good way to distinguish between them? Here we go. Continuations are some computation, or both of them some computation that's going to happen at a later date. Futures are all memoization, and having memoized the answer, you get it again every time you ask at low cost.
Futures had quite a precise value when they were first introduced, because at the time they had eventual values, which is like what we'd call a promise today. And the whole research contribution to the paper that introduced futures was the idea that there was no wrapper type, there was no future type. It was the value was indistinguishable from a non-fulfilled value from a filled value. As soon as you tried to access it, it was blocked. And that's what, so any language that has a future T type is getting it wrong, because that was the whole idea of the paper.
So if
was that you did not have a type.
If you're going to block, that's not future at all.
So how do you know that it's not available?
No, sorry, it does block. It transparently blocks, but there's no type difference.
What I'm saying is the underlying operating system, how does the underlying system understand that the value is not available and it must block?
What it does is the value does have a sort of boxing to it, but when it has fulfilled, then all operations get
so it was in fact, the implementation was in fact put a box, and the future T you get out of Java and everyone else is the box made explicit.
Which is the whole idea not to do that.
But the point is that you build a wrapper type around it, so you can use it with a map, flat map, and etc. etc. You build the API around the value you wrap. That's the whole point.
You wouldn't necessarily need a wrapper type for
You don't need a wrapper type, but you use it like an API to wrap the value.
Yeah. So in my case, I do have a wrapper type, but it doesn't actually show up in the type signatures of stuff, for example. So if you have, say, the whole system is a little different, but if you have a method that essentially runs asynchronous, you don't say, oh, it returns a future of type, string. You just say it returns a string. And the compiler goes, wait, we know this is an async method, so it's actually returning a future.
It's like an implicit async await. You can use it like a regular method values. You can use the methods and transform.
I go back and forth on these kinds of how much you hide at games, because you also hide the cost model.
Right. So in my case, there is a specific method that you have to call to check and get the underlying value.
Oh, I see. So it's declared a string, but I have to call string.getFuture or something.
So let's say on the producer side, you define your method. You say, oh, it returns a string. You just return a string. On the consumer side, you do x equals that thing. If you then want to get the value, you have to do x.get. It doesn't sort of automatically dereference or redirect whatever.
Yeah, so x equals got you a future, not a string, and you had to get.
Yes.
Okay. Even though the signature declared it was returning a string.
Right.
Okay.
And then in this case, because I have an ownership model, once you get the thing, the future itself becomes invalid, so you can only get it once. And that's also
it doesn't just become a value that you can keep getting over and over again.
Sorry?
It doesn't just become a static value that every time you call get, you get the same thing again.
No, it's more like you have an option and you unwrap it, and then the option becomes invalid.
Right.
So basically, I passed you a function, and the argument is when you call this, I'll go get the thing.
Essentially, it's like a one-time function call, essentially.
Interesting. Yeah, I certainly did a lot of stuff with continuations at H2O. But there, commonly, you're looking for side effects because the data manipulated something on a remote cluster. You couldn't have the data locally, it's too big, so you're doing remote cluster. But you need to know it was done, so you had a block for it or a get for it. And there, the issues I was running into is like preventing deadlock cycles where A depended on B, depended on C, depended on A, and then you deadlocked around the cluster. There's a lot of that games going on you had to deal with.
Yeah, I'm currently using futures to do transaction processing code.
Yeah.
So specifically triggers, which can be infinitely cyclic.
What are you doing about cycles? I have my answer.
Well, right now I'm hard coding a limitation to the number of cycles it'll take before it blows up. But
so you're doing some cycle counting as you go, or the runtime evaluation says, hey, wait a second, I'm back around to where I was before. It's time to blow.
Right, because you could imagine, it being accidental. I have two two different structures, A and B. A has a trigger that updates B, B has a trigger that updates A,
Yeah.
and before you know it.
Oh, you have triggers for updates as opposed to lazily computed value. A has done a bunch of work and needs a value from B. B does a bunch of work, needs a value from A. Deadlock.
Right.
You're not talking about that. You're talking about something
No.
different.
I'm talking about something. I'm talking about triggers in kind of the relational sense of a change has occurred. There's some automatic.
Propagate the change. Oh, that made a change. Oh, propagate back, and now we go round and round. Yeah, but you allow more than one, as opposed to just declaring it an error. And if you want to update A, update B, you have to do
Correct. And we also support asynchronous triggers. So generally speaking, you don't want synchronous triggers because they are kind of provably single-threaded.
Yeah.
In a sense.
Yeah. Okay.
So a synchronous trigger is one that evaluates between the prepare and commit phase of a transaction.
Okay.
And an asynchronous trigger is one you get to throw over into the future. So.
Oh, I see.
These are in-memory transactions, not transactions over durable storage.
These are over durable.
Yeah, as soon as
or in memory, whatever. It's all the same.
Right. Yeah, it's all the same. Just one adds more or less latency than the other, but it's never zero, and so there's no infinitely quick. So therefore, you have to deal with time, and something happened in between, and it could be a clock cycle, but one is all it takes, and then something happened in between, and you're screwed.
So on the subject of futures and such, this is more sort of a question I sort of know the answer to already. So in my language, in the sort of original implementation, I had support for both getting an individual futures value and essentially polling multiple ones, kind of similar to the classic poll 2. I ended up having to remove that. One, because you get the same issues as poll 2, where you poll 10,000 futures, so you have to check 10,000. But two, because of how locking works in my implementation, it wouldn't actually be thread safe. Specifically, the process of getting a future involves locking two different data structures. That is, you lock the future to see, hey, is there a value? And then if it's not, you have to update the status of the process that's waiting to indicate, hey, it's waiting for a future. And then also you flip a bit in the future saying, hey, somebody's waiting for this. The idea is that once somebody writes to the future, it can check that and say, hey, there's this process waiting. Let's reschedule it immediately.
Yeah.
So you get this thing, two things have to be locked in the very specific order, because otherwise they can deadlock. And getting that.
You do that with a CAS, right? So because you get an indication whether the CAS actually changed the value. So if you're the one setting the value, you CAS it from the does not exist value to the actual value. If it succeeds, then you become responsible for the notification mechanism.
You can flip the sort of, somebody's waiting for this future bit. In this case, the status per process isn't just a single bit. It's basically multiple bits packed into, I think I used a 16 bits integer. Or just a byte, I don't remember. But even if you do CAS on both, you still have the timing thing where, because that was what I originally actually wanted, is atomics. But then you get this point where you say, hey, do we have to reschedule? No, okay, do sync. And then you basically have to check again. Because otherwise, depending on the order of things, you may miss out on rescheduling something. And then it may take
so normally then you'd put them back to back and then don't CAS it as an 8-bit, but CAS it as a 16, or don't CAS it as a 16, CAS it as a 32. So that you're basically saying as part of the CAS operation, only succeed if no one is screwed with the other half of the data.
Yeah.
Right.
And then you run out of bits, unfortunately, because certain hardware doesn't allow CAS above a certain size. And that's the problem in Java, if you remember, with the 64-bit longs back in about 2000, they couldn't do it because Intel only supported a 32-bit CAS.
Right. All right. So this can be done with like 2 bits. This is like Douglas fork join. This is like 2 bits. There's a bit saying somebody's waiting or not, and there's a bit saying it's done or not, and or it's the value. And the guy who CASes it to being it's a value, he picks up that it's got waiters, and he then runs off and go gets the waiters.
Right, and the challenge here though is that the essentially two structures. They are not in the same thing. In fact, they're in different regions of memory. So you have the structure that represents it. Sorry?
The pile of waiters?
No, so in my case, I have a structure that represents a process, that lives somewhere.
Okay.
And then I have a structure for the future, which lives somewhere else, because the consumer and the producer need access to it. And you can't cast on two different things in memory.
So if you built up a lot of these async things, how do you decide what to work on next?
Okay, wait, that's a different problem altogether. That's how you do workless style algorithms for doing efficient computation. Again, I encourage you to go look at fork join work. There's a lot of people do this too. So let me set that aside for a second here and sort out your work's thing. There is a people piling in on a I'm going to go to sleep thing because the future is not available and they're not responsible for computing it. And then there's a guy who's busy computing it and he says, I'm done now. I want to go wake up everybody and disallow future people from coming in on this future. So he flips the thing in the future and now, but after he flips it, no more new people show up on the waiting list, but old people keep dribbling in. So you have to go to the waiting list in CAS a second time. The wait list is now not taking new people, the value is available. And the one time you have to do a double hit is a reader might read the future, see that it's not available, read the wait list, see it's not available, but now he is hard guaranteed that a reread of the future will get him a value. And that's it, you're done.
Yeah, it's probably difficult to discuss without spending like 2 hours going through the code.
I do this kind of concurrent shit all the time.
No, right, but so in this case, the sort of problem was basically you can probably do that, but you end up having to be very careful about getting the timing right, because otherwise, a process may observe there's no data, suspend itself, and then it can take forever to wake up, or you can end up rescheduling stuff twice, things like that. So I opted to just go with locking.
There's always a case that somebody has to do something twice because they missed. Unless you can fit your waiters list in the same word you're atomically casing, which typically you cannot. Okay, fine. So there is a cas that is done that says no new waiters are allowed to appear. And that is independent of any future thing. If I just have a wait and notify system and I want to implement wait and notify, somewhere in the world there's a wait list and I want to go on it, but the answer was it's been notified, you can't go on it now. Right, and instead you've been notified and you're done and you get out of there and fuck.
So what I did with this is Mark, I don't know if you remember this from years ago, but I did a prime number. So you'd grab a prime number modulo by 61, which is the largest prime that fits in a 64-bit, and you'd each take a bit slot. And then one of the leftover bits was the everyone. So it supported shared locks with notify up to 61 waiters, assuming you didn't collide. And then there was some.
You have to do there's always a horrible backoff path that turns into exactly what I'm saying. Path. If you handle the horrible backoff path first, then you can optimize and say, hey, there's a shortcut here in a lot of cases. Like the future can know that there were no waiters and as a first cut approximation.
Right, but then you'd get shared and exclusive locks for a total of a single CAS.
Yeah.
With notify.
Well, with your extra bits for the pile up until you had more than 64 waiters, which it's not a bad answer. On an Azul box, you'd have 1,000 waiters and no good. On an x86, you can get 64 if you try hard, and that works pretty well.
Okay, one hard question about the futures. Future cancellation. Do we support it? How do we find
same
strategies
as anything
and
else.
future chains? Of course, the future chains, a future code.
You cancel a future by casing in a bit saying it's done. It has its answer. The answer is cancel.
But all the futures depend on that future.
No, then the guy who wants the future already wakes up and he gets the value, and the value is cancel, and he has to deal.
And I don't exactly know the full story, but futures are prone to space leaks somehow if you cancel it and
garbage
leaves it hanging. There's some.
This is many concurrent algorithms are hugely easier with garbage collection. because the lifetime management of individual words you're casing and passing around are very complicated to know who's the last man out.
Turns out that RAII doesn't work well across threads.
I'm sorry,
RAII doesn't work well across threads.
Resource acquisition and initialization, something.
Yeah, C++ model of unwinding.
I don't like
Yeah,
it.
the idea there is
I don't like this
resource
model at all.
initialization is resource allocation, and getting rid of your access
That's
to
the
that
one.
is freeing it.
That's the one.
Yeah.
I much
Yeah, so
prefer
when you're,
that
when you're
defer.
talking with C++ developers who never have used more than one thread, it's the answer to everything.
Yeah.
I believe defer keyword it's much more flexible and much more reasonable. Defer and when you end up in the scope, you deallocate, but you don't do it in the class, the structure, and blah blah blah. You
Yeah.
just write defer, and when it leaves the scope, it's all.
They are actually really annoying to implement, funny enough. Like I'm actually getting rid of them. I had them.
Which ones? I'm sorry.
Deferring statements, so similar to like Go, a couple other languages have it.
Delete or on delete or something.
Yeah, like scope guards, they're sometimes called.
I've well used and enjoyed lexical scope destructors. Destructors that have outside the Java finalizers totally sucked in many ways. Lexical scope destructors were great.
Yeah, so in this case, generally you do like defer, you give it a function, and at the end of the scope, it runs that function.
Yeah.
That's whatever it does.
Yeah, it's usual that you do a lock on entry, and on every exit path, the compiler threw an unlock.
And so
but only if you can prove it doesn't escape.
No, on every it's lexically scoped. Leaving the scope runs the defer. Right. It's nothing to do with lifetime of anything.
But you're required, do you remove them? Why?
So it's a mix of different things. Like the sort of underlying reason is I was moving away from garbage collection to a single ownership system, and then you automatically can more or less get destructors for free. Yeah. Which kind of nullifies the reason for defer in the first place.
So reference counting, but you're only allowed to count to 1.
Sorry?
So reference counting, but you're only allowed to count up to 1.
No, it's hold on.
Is it more like a Rust style?
Yeah, closer. Let me get the paper I shared it before. What was it called again? Ownership. You can count. Oh, I have it bookmarked even.
Yeah.
It's kind of like reference counting, but without the suck, basically. I
was reading Apple's Swift's ARC reference counting, and they hit some suck points because of cycles. Yeah. Manually programmers to break cycles is pretty suck.
This, of course, has its own challenges, but it doesn't have these. But anyway, so one of the reasons I got rid of it is because I'm adding destructors. The second is you have a couple of ways you can implement it. Like first, you can do it statically, where you sort of take that scope and at every return and throw, whatever, you just sort of copy paste that code. My compiler was shit, so I didn't have that. I had it in the runtime baked in, where basically every stack frame had a list of the functions to run, and it would run those. But then you get these issues like, oh, you throw, and you have to say unwind 4 frames. What you have to do, every frame, get that list, add it to the parent one. Oh, we're going to unwind again. Do that again. And then what makes things more complicated is that my scheduler is similar in Erlang in the sense that I control when processes are suspended. They're not tied to like the native call stack or anything. And I support suspending basically at any given point, more or less. The result is basically whenever you, what was it again? When, either way, there were like a whole bunch of places we had to make sure like, oh yeah, wait, if we do this, first we have to make sure that we run any of these pending defer blocks.
Somebody throw an exception that you're looking for here?
It was, I think, so I had one complicated, I had method returns. So if you had the nested closure, you could return from the surrounding method, which may involve unwinding from like 15 call frames. That means every time you have to, run those pending ones.
You Stack Overflow?
There were basically a whole bunch of places where you have to do something like, oh, if we have pending defers, run them.
Yeah.
Or move them to the parent.
The DOPS.
And it ends up
But-
getting quite annoying, and it's not super efficient either. And you also cannot inline them because the VM needs some sort of function thing it can run.
So how about if it captures something or something escapes in the closer and you cannot defer it to temporarily allocate it in something like a region and deallocate it all at once? Something like a scoped garbage collector.
Yeah, so in this case, like because I was using a garbage collector, captures were not that big of a deal because if the deferred function survives, so does whatever it captures. There were some issues, I think, where you could trigger unsoundness, mostly because my implementation was crap. But it was the sort of mixture of being able to return from the surrounding method, having throws, having a custom scheduler, a bunch of things combined. Was like, okay, really the few places I used it was because I didn't have destructors.
Yeah.
And then I think is if you have destructors, you can always implement defers using that, but not the other way
Exceptions
around.
and futures are also a huge issue because that's they tend to disappear.
You have to stitch them manually through the threads and to call the error stack in order to show them in a proper flow.
Yeah, so Java loses unless you're really careful as a programmer, you lose all exceptions from futures.
That's you get.
That's if you're doing like completable future, right? It's all great as long as someone calls get.
Yeah.
And no one calls get. It's like, exception. What exception?
Exactly. Yeah. The other game I ran into was standard JUnit testing, where you do a future that had an error because it was a test, and the error got swallowed by the future. So the test passes, but it's all a big lie because the future didn't pass the assert fail out.
It will fail into the future. That's why it passed.
Yeah. Yeah, that was, I did the same with H2O, a lot of closures, continuations, same problem. If you didn't call get, like no compiler support. So no language support. If you didn't call get, it silently fell on the floor. Sometime later, everyone would be waiting, a billion people ran, the 1,000,000th guy didn't. Everyone's waiting for the last guy to come back with the answer before they go to the next step in the algorithm. Yeah, we're all waiting for somebody. No one's out there. Who are we waiting on? Where'd you go? What happened? Some corner case failed to do something.
Yeah, so in my case, the futures, the exceptions are raised when you get a value from the future.
Yeah. But if you fail to get, you throw the exception away.
Well, so you can't fail, like a get itself can't fail.
No,
as in,
you fail
if there's no
to call get. I said,
what happens if you create a future and no one ever comes looking for it?
Yeah. Mr. Remote function call x equals the return string future. I never call x.get.
So the future, so there's a couple of things. If in the case where I try to get a value from a future and none is written, the process that tries to get it will just be suspended until the value is
waiting for
present.
the future to get written.
If I write a value but never get it, the ownership system is such that when the futures have two parts of producer and consumer side. If the consumer is dropped and no value is present, it will sort of mark the future as disconnected. And then when we write a value, we see that, and you say, oh, screw it, we'll just drop the value.
Okay.
Similarly, if I write a value, then just drop the future, it will also drop the underlying value.
Okay. That sounds
so you don't end up with like a future that has a value, it's dropped, but then somehow the value is leaked because nobody ever cleans it up.
Right. That was my question. Because you have
the future
model, you can do that.
I mean, assuming the future gets leaked, then yes, so does the underlying value. But
was your system reference counted?
So owned values are not. References to them use reference counting, but they are not recursive. So it's just like, oh, I have 15 references. That's it. And when that owned value is dropped, and there still are references, kaboom, the whole program errors. So yeah, theoretically, if there's some sort of mechanism that allows you to forget about a value, you could use that with a future and say, you know, forget about this future, thus forget about the underlying value.
Sign
But that
null
would be
into
an
x.
Sorry?
Say x equals, give me a string of a future thing. Then later
Yeah.
I say x equals null. Wouldn't that?
Then it will run the destructor of the existing value.
Yeah, okay.
So it's similar to Rust in that sense, where if you know x is y, x is z, in between it will sort of inject, you know, a y.drop or something like that.
So if there's an error in that future, no one ever got it, and then you lose the reference to the future because you returned and the scope went away, does the error happen then?
No, the error.
So you say return and the error just goes away with the future, the whole thing gets.
Yeah, so if you were to error into a future and then basically never use the future, the error does not surface because you never got the value which includes the error.
That makes sense.
When it tries to drop it, it would just get the value, just drop the value. But if there's an error, well, the value can be the error. So there's basically a flag that says, you know, hey, this is a normal value or an exception. The drop logic is kind of similar, as in it'll just get the value, but it doesn't really rethrow it. It just discards it and that runs the destructor.
Yeah. Oh, that makes sense. You're not asking for the value of the future. The value happens to be an error. No one cares because you're not asking for the value of the future. Yeah.
Right. And so, yeah, theoretically, you could swallow them, but you would have to explicitly ignore the future, basically. Like it doesn't happen by accident. Somebody has to explicitly say, yeah, it's future. Yeah, we don't care about it.
Right. Yeah, that was the bugs I had in H2O was that we cared about it, but somebody didn't explicitly mark it as we care about it. And so it got dropped by accident. And then in the end, I would count 1 billion people and be off by 1. It would suck.
Yeah, and there you could do something like Rust where I believe types can be annotated with like must use.
Yeah, I needed something along the lines of this value is going to show up somewhere.
Yeah.
A long chain of passing a thing along that we're still using. Somebody threw an exception and the exception handler didn't say, and still this thing that's being passed along is also being used. So we'll locally handle the exception here.
Yeah, and I have been thinking about adding something like that, but I haven't come up with syntax yet for like some sort of like type attributes, whatever. Like Rust uses £, square brackets, but those are my comment characters, the £. So.
Oh yeah. Okay. Okay. Wait.
But yeah, probably eventually something like that. There will be some sort of annotation to say like, hey, you must use a future. Like you can't just assign it to like a variable and then not do anything with it, for example.
So /* comments nest or not?
I would argue you shouldn't have those comments in the first place because then this whole problem goes away. Just
well,
have
so you can
comments.
block out a big chunk of code.
Well, nesting
block out a bigger chunk, but
so I use a plugin for that. Like I select it and it will just comment out every line for me. It's nice if you have like a big if you just want to do the start and end or something.
That's a fair answer. I certainly do // when I'm chunking out code, and if I need to chunk out a bigger chunk, I put a taller / chunk.
Right.
It's done. Maybe that's the right answer, and I don't care no more.
No, because I think with multi-line comments, you get these issues like nested comments. What should the syntax be and things like that.
Yeah, right. No, you can answer that as don't bother to have a multi-line comment. Just use fucking //. And the other one is I have little tiny / comments because I'm trying to take a chunk of a test out of the middle of a complicated test expression, for which the easy answer is I should just clone the line, comment the good one, and comment the original one out, and the new line I just edit it however I want, and then I can unwind that easy enough. I think that's good.
I don't know. There's definitely been times when the ability to do an inline comment is useful.
Yeah, an inline comment. I have used them. And okay, fair enough. I usually use them once a week or something. They come around often enough. Big block comments I usually use for documentation purposes only, not for commenting out big chunks of code. When it's commenting out big chunks, I'm doing just what Eric said and lining up the // on the left.
I need to drop out to do something else. It's nice speaking to you all.
Yeah, well, we're actually getting close to time. So yeah, nice talking to you. Feel free to come around, next week. You're on my mailing list now. You'll get an invite until you quit showing up.
Great, thanks so much. Bye.
All right, bye-bye.
Yeah, I could drop out as well. So see you all next week.
Bye-bye. Yes, I'll agree with this. Yes, Turing complete templates.
Yeah, you can have infinite compile times.
Oh yeah, no, I've seen the program that was computing prime numbers in template error messages. The line number was faked up to be the next successive prime.
Yeah,
So
I mean, just
Cameron-
imagine having a popular header file and then putting a Bitcoin miner into your template.
This sounds like a real interesting denial of service attack, just to go hack on,
But C++ is a denial of service attack.
All right, but now you're trying to make money out of it. All right.
So Cameron, we will drop. Will we at the end? I was about to ask Cameron, what's the type? What is a type?
Oh,
What is it?
gosh.
What is a type? I wrote something on
Yeah,
that.
you threw that.
Yeah,
out
I
there.
read it. I'm just kidding.
What did you think?
You are close. It certainly has a practical motivations. A type is definitely in some way some of its behavior, of course, but there is still gray areas because of the type can be a value and can be a set of functions that define its behavior. So it's really tricky to define it as a behavior. In my opinion, of course, the most type and logicians and type theory person just sidestep the problem with say there is a function from A to B, and that's it. How that function is implemented is none of their concerns.
What are you writing here, Aaron?
It lost the new lines, which made it more confusing.
Yeah, I
But
was trying to. Yes.
that was my thing with what is a type of.
Oh,
It's
yeah.
sets of possible states and the intersections of them and the unions of
Right.
them.
The
Tagged
type-
unions of them and the sum types and product types and exponential types.
The type theorists love to have the union and intersection types as part of their typing, and they have strong theoretical proofs that it works, but they don't have strong theoretical proofs that it works efficiently.
That's actually what led to my misunderstanding what you meant by tilde type name. I thought it was the complement, as in it was all of the types that were not, all of the possible states that were not of the type.
No, it's the other
But
side.
it's not the
of a
complement, it's the reflection.
It's the reflection. Yeah, it's the other side of a symmetric lattice.
Yeah.
Which then turns into this funny, interpretation problem that we've gone around. This is half a conversation with guys from my type theory group that I'm doing Tuesday mornings.
Yeah, reflection is not complement was definitely the part of that confused me most.
Yeah, that one took a while, but we had a lot of jargon to sort out. It took about a month to sort out jargon issues because there's a lot of confusion there.
Although I got to say, I'm still not super clear on the usefulness of the reflections and when something is typed as reflection of integer.
Yeah, so the reflection type lets me have a lattice that's complete, bounded, has a bunch of other properties, and is implemented with dual and meet as opposed to dual and join. And the dual is trivially a bit flip. So there's that aspect of it. Now,
what is the situation when I would need to join something and reciprocal something?
So it turns out that your meet has some other issues now. So the meet got more complicated. That was Lionel's take on it. Meet got more complicated, so it didn't help you anything. My observation, having done this in C2 hotspot 25 years ago and doing it again in AA, is it works fine. The thing that's actually new, this is what Alan Mycroft was trying to go around, is I get to hold on to ambiguous states sort of perfectly indefinitely. And that lets me delay decisions about typing until I know more information. And if I have an error condition, it lists the set of ambiguous things that are causing the error sort of precisely. So for me, it's fundamentally useful. It also implements weird aspects with join on casts, just come for free out of it. In case you start casting, you know, impossible things together, I can sort it out what the hell it means. So I'm enjoying using it. It doesn't have a strong theoretical advantage that I can point to right now, other than the implementation seems straightforward. My lattices are a lot more complicated than what the type theorist guys are looking at, so they don't have an implementation issue like I do.
Do you have a visualization that will print out your whole lattice? So that it could just look at it and be very explicit?
I don't. I have nearby things. So I do a lot of test lattices that are essentially ASCII grams of a lattice that I interpret and then basically run a little analysis on to verify they have a lattice. And if I don't, it tells me something smart about why it's not a lattice and where I've got extra edges and where I have missing and da da da. So that one gives me partial lattices that are kind of reasonable to look at. But it's not like Seafoam's, you know, pretty printing lattice thing. The actual lattice would get pretty big. I've listed all the parts to it before, but I guess it's not infinitely huge. It's not actually, now you said that's probably not actually that big. There's like structs.
I mean, it's certainly less bad than the control flow graphs.
Right, yes, exactly. So there's a finite count of things. There's ints having their structure, whatever the structure is, ranges are int 8, 1632s, and floats the same. And there's structs and tuples as types. There's some higher and lower pieces of types that represent joins or intersections of these things. So scalar is all things that can fit in a register, and anti-scalar or twiddle scalar is the inverse of that. There's memory, which is a collection of objects, whereas or structs, objects, and structs are a collection of scalar values indexed by field name, and arrays are collections of scalar values indexed by number. And then I'm sort of running out of things. Oh, functions, and functions have their type. So then I'm sort of running out of things in the lattice. It's just that the behaviors are more complicated than they look in a lot of ways. Like I have recursive types. So a struct has a field, has a pointer to an element of the struct. So that's a linked list, standard recursive type. And some of these academic typing systems do recursive types and some do not. Yeah, what is a type conversation? Yeah, I think the difference here is, if not my system, but if I look at what was talking to these academic theory guys, if your types are sets of values, then the semantics are understandable and they can apply a higher order of analysis to prove properties that are exciting. Whereas like it's sound and complete and you terminate, you get the same answer all the time. Whereas if it's a sum of behaviors, then I have to do my analysis on the behavior, but I don't know what all your behaviors are exactly. Whereas if your behavior is that I'm a set, then I have my behaviors.
Why does it matter?
Because then I can prove something about the typing system.
I don't think you can prove any more or any less.
Well, okay. I claim that I know how the academics prove using set theory. I don't claim that they would be able to pick up behaviors or functional behaviors and make a proof out of that.
I believe that you can distinguish their types by their behavior, but what is behavior in this case?
If you assume, right, okay. If exactly the behavior maps a set, then I claim you have the identical, you're giving the same description, yes. Just two different ways. I've developed the set by executing a function that gave me the members of the set. Okay, I have a set. Okay, I can do set math, and they're totally going to be pulling out set theory to make their proofs.
Yep.
Whereas if your behavior is, if it's this, then that, if it's this, then that, if it's this, then that, if it's this, then that kind of thing, you have case analysis from hell to prove anything useful out of that, right?
Well, to some extent, I mean, Cliff, I mean, the way you said it the other day was, you know, you don't have functions, you have a field that holds a pointer to a function, right? So you turn everything into a structural type. So your behaviors
You're talking
so
about
to
the
speak.
subclassing style behaviors or functions being tied, describing an object via its functions is done by having fields that point to function pointers. Yeah. Yeah. Okay.
Right.
Yeah.
So I'm just saying I have that flipped on its head. I have fields that I describe by functions as opposed to, you know, offset
well, no,
plus
I'm
4.
I'm not defining my typing system this way. I am defining the underlying typing system this way. I'm defining user provided types as they have a collection of functions which map A to B's or whatever it's going to be, but those are not themselves defining the typing system.
How would you differentiate a type that has only odd numbers and only even numbers? Because they distinguish it by the values.
So I'm not, but I could add such an element in the lattice.
Yeah.
The set theory guys would say I have a set consists of evens and a set consists of odds.
Because if you have the type is sum of its behavior, you have to run the function to know the value if it's even or it's odd. That's why that's where it gets more complicated. Did you get my point, Cameron? I'm trying to.
No, not really.
And I'm not certain that Cameron and I got why I think it's unrelated to say that I'm defining user-defined types by having the struct have fields which happen to be functions. I think that's an unrelated to the implementation of the typing or the theoretical description of the typing system.
No, but I liked that choice because what you did is you normalized to a structural model by doing so. And yes. I think it's brilliant. Like
I'm hoping that it simplifies all those things. If I can do structural, I can do it with subtyping behavior.
Isn't that still structural and not behavioral?
My model.
Yes, it is, and that's what's brilliant. Like,
structural.
That's why it works.
Yeah.
So if I have a queue and a stack, and they each have two things, which is put and get, and those are the only things that are there, the queue and the stack are not really subtypes of each other, even though the type system is going to say, oh yeah, these are totally subtypes of each other.
If you're talking Java code and you have a queue and a stack, and they both have puts and gets, why are they different? The implementations are different, the behaviors are different, the name's different.
Yeah, but Java doesn't have a structural typing system. Java has a nominal typing system. So let's take that off the table. Let's look at AA. So if you had two types in AA, they each had two fields, one called put, one called get. And put and get happen to be functions that took and return the same types, then they would be identical types in a sense.
They would be all types as defined are anonymous and different unless you've copied one to another. So these would be two unrelated types that have the same signature, can be applied in the same places. If people just call get and put, can take you or a stack, but they're two different types. Because they were.
I mean, you make the rules for your type system, but you could
defining two different points in the program.
Yeah, but their performance characteristics differ.
Yeah, no, they're two different types. But the performance is whatever queue and get. One of them computes Fibonacci to the nth power before it returns a result, and the other one doesn't. One of them sleeps a year and then does it. I don't care. There's a completely different execution. There's no performance implied by the types. How about that? There's no performance implied by the types. The question I heard was, if the signatures look the same, aren't they the same type? And the answer is yes. Are they the same object computing the same thing? No. Two different objects. One's a queue object, one's a stack object. Same type, different objects. That's a better answer. So it is the same type. I was trying to think of why the different program, the same thing appears two different places in the program. It's the same type. It's the same type. Done. I think that the usefulness there was getting rid of subtyping in a classical Java class hierarchy model and replacing it with structural, including all the functions as well. And that's just a way to simplify for me.
Yeah, we simplified by going straight behavioral instead of straight structural. But we also have nominal as well. So we have a mix because if you're only behavioral, then everything is a duck, right? No, that's purely duck typing. So duck typing for us was free.
I'm claiming that I don't know how to prove correctness in a behavioral model. Whereas in a lattice, I have a certain set of algorithms and theories to use, and in a set theoretic model, I have a different set, but related set of things to use for proving properties.
If you when you said behavior, does this imply a function? So a set of functions. What does it really mean from your
Well,
standpoint?
throw your link out again. Didn't you have that link?
Yeah, I read the article. I read the article, but it's still not clear.
No, it bottoms out too quick. You stop with, and I have all these behaviors, which then now leads to all these questions about what happens when I do this and this and this.
Well, I wasn't writing a book.
Yeah.
Well, I get it.
Yeah. Because when you set a behavior, what does it mean? Does it mean a set of functions? Well, is some of its behavior okay? I can.
It's a set of. It's specifically a set of methods.
Set of methods. Okay. Okay.
Yeah.
If this is so, I believe we are in the lambda calculus land, because how the language is set of functions.
Oh, you're saying the types you execute some lambda calculus? I think that's not how typing works.
No. If you said earlier to prove something about the type system where there is a behavior, if the behavior is set of functions, lambda type calculus, the core of the lambda calculus is a function. It's function based, but it's untyped function based.
Yeah, it's untyped. Right.
We can equalize the properties if they are methods or functions. We can equalize to a lambda calculus type system.
Yeah, and we're strongly typed.
Okay, so we are typed at lambda calculus. Okay.
Yep.
And I believe we can.
On the cube, we're everything except dependent types. I mean, we did not implement. Well, we didn't fully implement dependent types. We have dependent types for enums, and that's pretty much it.
But the enums have a concept of identity, right? If I have one enum that's days of the week, and it's the numbers 1 through 7, and I have one enum that's the colors of the rainbow, and it's the numbers 1 through 7, I don't necessarily want red and Sunday to be equal to each other.
Of course, yeah. There's no there.
Yeah. Well,
that's not even. Yeah. Yeah. So we have a
right. But if I have a pure structural type and I have an enum, and at the bottom of my enum was an integer, and it maps to the same integer, you don't want to accidentally have a quality.
That's correct. We only use duck typing. We only use duck typing for interfaces. So you would only be able to ask the question: Is this a duck? If duck is an interface.
Something like Go. If it has these methods, then it conforms to some type.
And that's because the UX of an interface is a junction point between modules quite often. And so being able to duck type, let's say that someone, so there's a library I want to use, library A, and I also want to create library B, and I can plug them into the same point. Library A was written by someone else. So what I do is I define an interface that library A happens to implement by duck. I implement the same interface on library B. Now I can plug either module into that plug point. So at runtime, I could have instances from A and instances from B plugged into the same thing, even though I didn't go back and rewrite A to make that plug happen. So it's a user experience. So for me, the duck typing is all about user experience, and when you're working with other people's libraries and you want to do something like that, it's handy to not have to go change their code.
So when you say duck typing here, are you actually structurally typed? Where duck typing would be Pythonish runtime only, and structurally would be link time, typing time only. You would confirm you matched the signature.
Well, we can do both.
Okay.
But sometimes you don't know what the type is until runtime, because type variables. That was the conversation the other day, Tuesday. Because we may be given a T, which is a type, and then only at runtime can we say, hey, is this T that interface?
But
is it castable to that interface, for example?
Yeah, but this T all by itself doesn't tell you much. You have to refine its behavior. In Scala, you would say that is a subtype of
Yeah, he
some
just
other
said
thing.
you have to do an instance of cast. I mean,
We can
it's-
do, right, we can do an is or an as. So an
Yeah.
as is an assert
Okay.
and an is a test.
That would manifest in the runtime. How do you check the T has some properties at compile time?
Well,
Some
first of all, you
interface.
can define a constraint for it. So you can say that T has to extend blah or whatever.
Okay.
But you just do an interface test, same as, oh, in Java, they're nominative. Now you have to do a
Right.
duck typing test.
Right.
Yeah, correct.
Yeah, so you have to do an efficient, presumably an efficient duck typing test. You have the following,
There's
set.
definitely a worst case edge on a duck type test. And since we have no intrinsic types, we actually have to pick some types to act as primitive types. So function, for example, Gene,
Yes.
what are on duck typing, what are our intrinsics? What do we wire
By
to?
intrinsic here, you mean
Function.
axiomatic types?
That's what I'm trying to understand too.
Properties,
Properties,
methods.
methods, functions, types?
no.
No, okay. So properties and methods, those are the,
Only for interface.
right. So
So
properties and.
Properties with the
and
same
methods.
name and signature?
Yes,
Okay, and methods with the same name and signature, properties the same name and signature.
yes, both.
Yeah, where properties are just a pile of more functions, basically. They may have state backing them, they may not, but they're a pile of functions.
So sorry. So if you have two methods, so two interfaces. So I'm trying to think of how to.
You had a
describe this.
concrete thing and an
For
interface.
duck typing, there's something that we don't go beyond for consumes and produces. Where do we stop? Where's the end of the recur? Where's the bottom turtle?
We don't analyze that
It is turtles all the way down.
to an interface. You can only duck type to an interface.
Right.
Right?
Yes.
For class,
Yeah.
you cannot.
But we
cannot
tear it
duck type
we
to a
tear it
class.
apart down to a certain type that we don't go beyond. What's the?
No, we don't.
Oh, really?
Just,
Never mind. Apparently we
Okay,
keep.
we do not hear this. Okay.
recursion. I catch your recursion and say no.
I see. Yeah. So infinite recursion is a false.
Right.
So there is a back edge to it.
I'm sorry, you're saying that duck typing test, the is test might go infinitely recursive?
No, we detect that it would go infinite, and that becomes a false.
Yes.
Ah,
So that's the bad back edge. Yeah.
yeah, you just need having,
I mean, you can do cycle detection and say, hey, are these two graphs isomorphic? But
right.
that's
Right.
at least NP hard, right? If not,
If you
full
do general
exponential.
graphs for isomorphism, it's NP hard. If you do labeled edge graphs, as is common for me in typing, it's not, it's linear.
Yeah. More the latter.
It's a complicated algorithm, but it's linear. I basically unroll both sides until I've unrolled them to where they've met again in the unrolls and take the intersection or whatever.
I do like linear better than NP hard.
Oh yeah.
Yeah, we do have one NP hard, which is the SMT.
Sorry, what's SMT?
Oh,
Satisfiability.
yes,
model tuning.
satisfiability.
You have a
Yep.
SAT going on.
Yeah. Well,
Yeah.
compile time only.
SAT is the weaker version of the SMT.
Yeah, yeah. SAT's ugly, and compile time only on ugly is still pretty ugly, but fine.
Yes.
Yeah.
Yeah.
I think I missed something. You're using a SAT solver in the compiler?
To do
Only
type
for
analysis.
conditional logic. Yeah.
Yeah.
So if def, if you will.
It is applicable, I believe.
This is exactly where I'm at in my current algorithm hacking. Is I have an if that you can cut out code, then I don't have to type or unify. So I'm exactly trying to do this in a linear time variant of the algorithm, not a stat solver.
I was
So in our
thinking about that.
constant
If you
pool.
prove-
Oh, go ahead. Go ahead, Peter.
If you prune one of the edges, you will prove that one of the arms of the statement is not applicable. Then you only use the left side, correct?
Yeah.
But okay, but if somehow the type has to be manifested, I mean, if the type has to be written out, as a return type, what would be? Does it always like I'm thinking the Scala return function. If you have to colon and write out what type would be if you annotated it manually, and the algorithm already pruned one of the arms, will this cause some troubles? Because
so annotation.
The point is to unify the both type and to be the most representative type of the if statement.
So annotations in my world order, annotations are stripped out. I type you, I then verify all your annotations are true, but they might be overly conservative. So if I have two arms of an if and I cut one of them out in the typing, I'll get a more precise type, and your more general annotation will be easily true.
Yeah, but here's an example. If you have a result that if subtyping, you have an interface and two subclasses of this interface. One arm is the one class, the other arm is the other class.
Yeah.
If you deduce that you don't need the left arm, you can just not conform to the interface base, but to the concrete type that is the left arm, that is the right arm. And this is the result type because you pruned one of the arm.
Yeah.
If you have to write it out, if this statement becomes false, if you have the need to do the other arm, does this will conform still to the type? Because if you have to unify them, it will say the base class is the most representative type, and that's it.
Okay, hang on.
Okay,
So
no problem.
Here's an expression where Milner would unify those two structs, claim that I get an X out of them both. The one gets a Y, one gets a Z. I don't get either one. So I can either, depending on who's Henley Milner and how clever you either get an error, or you get a structure that just has an X but doesn't have a Y or a Z.
Yeah.
Where if I will say, if it's true, I know I get a Y.
Yeah.
So I can
if it's
ask
false,
Y
you get X. If it's true, you get Y. If it's false, you get X. Okay.
And if I don't know, I'm going to get just the X alone. But if it's true or false, I get one of the. Yeah. Okay. So I'm sorry. Now, what is your problem, or what is the question here? I don't understand.
If you this is only true if you can deduce which branch will go.
Yes.
Yeah. If you cannot, you still have to emit the principal type of the if.
Yes.
Okay.
Yes, totally. So replace one with an arbitrary predicate.
Okay, this is only applicable if you can figure out which is the branch, which branch will go, the code go.
Right. So in the second guy, if I said .x, it'll work, but if I say .y, it'll fail. It'll give me a typing error and say there's no Y in your struct, which only has an X because you're taking both arms here, and X is and Y is not common. Whereas in the first line, I can ask for .y and it'll work.
Because you can figure out that comparison. Yes. Okay. That was my question. Well, what would happen if it cannot figure out? It would give the type error because it doesn't have a Y if it's asking for one on the left side. The right side has an X and Z, and if it doesn't know which one, it will have to ask for a Y. Okay.
That's this expression with the .y at the end types.
Yeah, it will result if it will result of something that has to have an X type.
Yeah. Well,
that has an X field. I'm sorry, that will have an X field. If you know at the first example, you know that the code will be else, and you asking for an X field from the else branch. Yes.
If the predicate is unknown or false, I'll get the other arm. Right. Yeah. Just sort of straightforward in the code. Unify it once, unify the other way accordingly, and you're done.
Yeah. That's why. I just thought about it, and you emit the principal type if you don't know which branch will be the code.
Right.
Now, so if I have a predicate where I can't tell which branch is going to happen, is there a way for me to later ask, hey, does this thing have a Y field on it? If so, go do this thing. Otherwise, know that it has a Z.
So in the typing algorithm that I'm running right now, I am blending constant propagation and Henley Milner. When the algorithm starts, the predicate has a high value in the lattice, and I don't unify either arm because I am above the center line. It falls monotonically to left or right, and then it falls to the bottom type for predicate, some Boolean both directions. And I pick up more unifications every time it falls.
Oh, I get it. I get it.
If you never fall, then I only took ever the one unification for the side it fell to. And that's the constraint you get for the result, which is now you type it how you type it after that, and it does what it does. Does that answer your question, Aaron?
I think so, but I feel like you have less information than you could possibly have here. Because what you know is that it has an X.
But
Like if I somewhere later in the program check, does this thing have a Y? That's not going to tell me whether it has a Z, even though that is fully determined.
So
right?
if later in the program you ask, does it have a Y? You do that by doing a load of the Y field. You get a type error if I cannot prove the predicate is a 1. Because I would then say the predicate is bottom, and therefore you don't have a Y, and therefore you would get a type error. So this is all typing time, right? I'm typing this. So it's not a dynamic runtime question. This is a typing question. Chat.
Oh, I think I get it. The
Well, I want
types,
to see Aaron, you same page yet, or this is?
Yeah, the thing that confused me is you essentially have two possible worlds if you can't look at the predicate. So my choices are I either try to carry around the number of worlds I have, it's either type A or type B, or I have to go up the lattice to something that consumes them both, and it's going to end up like, oh, they're both structs.
Okay, so we're getting in the right direction. Yeah. I am using a thing called a monotone analysis framework. The unification process only ever extends types as you unify. It never shrinks them. Yeah. So having produced a type with an X, I know for certain that it's going to have an X, but I don't know yet about Y and Z. If I later produce a Y, it guaranteed has it. But if I pull the Z along, that if I fall to the next step down, it's the other way around here. I'm going to lose the Y field as part of the unification. If 1, then I have a Y. If I fall, I lose the Y, and that'll be part of the unification story.
So if I have this line of code in my program, do I have to add 3 nodes to the lattice? One that is struct containing an X and a Y, one that is struct containing an X and a Z, and one that is struct containing an X?
I will add them, yeah. At different times as the algorithm runs, sure. They represent different types. Like types for me are hash const and immutable things that I throw together in quick instant time and have them floating around as freebies. And I use them at different program points according to what the analysis is sitting at.
So even though this line only has 2 structs in it, it adds 3 nodes to the
Yeah, there are 3
lattice.
unique types here, yeah.
Okay.
Yeah, it's actually a little bit more, because what I'm really going to do is say that if
you're going to add struct 1, reflection of struct 1, struct 2, reflection of struct 2.
Yeah. Okay. Every time I add a type, I always add its reflection immediately, and immediately have the dual point back and forth. So I have a 1 cycle, go get the dual. Yeah. So whenever you see 1, you get 2, but fine. So the other thing I said here is I add or remove a Z field. It's not actually correct. If I come to the guy where I say it's just true and I add the Z equals 3, by the way, types 2 and 3 will also appear, and the struct will be fields of other types recursive. Okay, fine. If I then bring in the else clause, the Z field and the Y field will be set to an error type. That if you then use them, you're in error. If you don't ever use the Y field, it's not an error. But I can't get rid of the Y field, or I am not monotonic. So having added a Y field, I have it forever. But if I end up unifying with somebody who does not have a Y field, then that Y field gets slapped down to an error. So I had an error type, and I have 2s and 3s and 3s and 4s, but I also have the unification of 2 and 3 for X, which is int 8, non-zero int 8. So I have a couple other types that float around that you haven't seen or you haven't thought about. There's a type for the integer 1. There's a type for the Boolean for the predicate. There's a type of the merge of 2 and 3. You know, 0 and 1 makes bool. 2 and 3 makes int 8 as a simplification. The meat of struct of x equals 2, y equals 3, and x equals 3, y equals z equals 4 will be a struct containing x equals int 8, comma y is error, comma z is error. And if you then ask for y or z on this thing, you toast. Now that, having said that, that's because of the way unification works in Henley Milner. You still get what you expect to have happen in a case where the types are all kept apart and merged here. So I'm going to write a little something. Hang on a second. It's just going to be very close to what came out before. So here I have types S1, type S2, and the predicate merges them. So on S1, I can always ask for Y. I can say S1.Y anywhere in the program that'll work, and say S2.Z anywhere in the program that'll work. But if I do the predicate, the if predicate dude, and I ask for a Y, I'll fail unless predicate is true or false. So in this program, I have types for struct x equals 2, y equals 3, and also struct x equals nint, comma, y equals error, z equals error. Or you get a bunch of different types here.
Yeah, what would be the principal type? What would be the union?
The principal type, well, now the principal type is whatever you get for the exit of the program, which right now I've just said is predicate of S1, S2. Yeah. That'll be x equals nint, comma, y is error, z is error. Yeah, which I'll pretty print as something that says you don't have access to y and z.
Okay.
And it can't combinatorially explode because to get the extra type, you have to be unifying at least 2 types.
Yeah.
And to unify on that one, you have to be unifying at least 2 types.
Yeah.
So sort of Zeno's paradox style, the infinite series is going to converge at 2. You can't have more than 2x the number of types that appear in the program.
Yeah. So now you're asking for execution time. Outside of Henley Milner, the lattice theory has provably linear count of types, provably linear execution time. You get the count according to the bound of the lattice, which is the height. Sometimes you can fall, which sometimes you can uniquely merge things as you go down things. When you add Henley Milner, the worst case blow up, I think, is exponential or it's cubic. It's one of these two.
Exponential.
And I have an example that does this kind of blow up, and I get a large Henley Milner type. Having said that, the lattice elements all look redundantly the same for such a type. So I don't actually get very many new unique lattice elements when I start blowing out the Henley Milner types. I get a horrific function nested blowout, however big Henley Milner blows out, but the lattice type is all, I take a wad of something horrific to something horrific, and it's a tiny little type. It's just A of anything to B of anything, more or less. And I'm done.
Okay, this is the example with if and else that we are analyzing in structural form. If these S1 and S2 are a base type of some interface, if we don't know what's the predicate, will we fall to the base interface as a result type?
Right. So you're saying if S1 is an extension of a base, suppose I have a base type which just has an X here. Yeah. S1 is an extension of the base type. S2 is an extension of the base type.
Yeah.
Without nominative typing, then as soon as you have an equivalent set of things in the unified side, you get a structurally equivalent type. So yes, you would get something that was structurally equivalent to the base class.
It will result in something that has to have a next field. Yeah, more or less.
Right. If I'm doing nominative types, then S1 and S2 better extend the same base class, because as soon as I unify them, I will chop back to the common base class. And then if I had to, mess with fields that were missing from one or the other, I'll get you a nominative base class that's missing some fields that won't be usable in all contexts for the base class. No, the base class would be the same. It would be usable. No, you chop back right away on the names. If I had nominative types going in, you can add nominative types. I can say I have a base of S0 and S1 is an extension of S0 with a Y. Yeah, you chop back to the base type.
Yeah, cool. I think I starting to get the hang of it. Of what is the whole exercise about? So the types flow always from the more precise to less precise when you follow into the lattice.
I use the wiki lattice page there, Aaron. I'll throw that up. This one is my go-to for what I'm doing.
Yeah. Cool.
All right. Why don't we declare victory here? It's 2 hours and people are getting, cross-eyed.
Yeah. Cool.
Okay. Well, till we meet again.
Thank you.
Yeah.
Bye. Bye.
Cheers.
Bye, everybody.